And welcome back. We are going to dive right into our next lesson here on this super constructor because this is the kind of the next piece that we need to look at when we're looking at derived classes. Now, we've already seen how to override methods, but now this is of course using constructors, and they function just slightly different in a derived class, as we looked at with some examples, than they do within our base classes. So how do those constructors within derived classes actually work? Well, the first thing we need to understand is that when you invoke a constructor of the base class within the definition of a derived class, you can still use those same constructors. We want to be able to do this because we want those instance variables, for example, that exist within the base class. So a constructor for a derived class uses a constructor from the base class in a special way. First, the constructor for the base class normally initializes all the data inherited from the base class. And then second, a constructor for the derived class begins with the invocation of a constructor for the base class. All right, so that's great. Now, how do we actually invoke this? Well, if we want to invoke the base class constructor, there's actually a special syntax for doing so. And if we look at our hourly employee, we can kind of get some idea of how to do that invoke. We'll see we say public hourly employee, string the name, the date, double the wage, double the hours. And then we have this super constructor. And it says super, the name, the date. And of course, it's passing in things like the wage rate, the hours, stuff like that, all those other things. But if we look at this, name and date, if you remember, are things that exist within our employee object. We don't have instance variables for name and date within hourly employee. Instead, name and date exist with employee. And so this is where this super constructor is going to come into play. So the super constructor is a pretty powerful little piece of code here. If we look at the line super, the name, the date, this is actually a call to the constructor for the base class, which in this case is a call to the constructor for the class employee. We use super constructors when we want to use a constructor from the base class in the derived class. Now there of course are some restrictions on how you can use the base class constructor call super. Now, for example, you cannot use an instance variable as an argument to super. The call to the base class constructor, again super, must always be the first action taken within a constructor definition. So when you write out the derived class, super should always be the very first thing within that constructor. It cannot have anything preceding it. And as I mentioned, very similar to that, you can't use it later. So the super constructor should always be the first thing there. So when we look at our examples, for example, like hourly employee, you're going to see that super is always the very first item within that constructor. Now, let's actually look at how we use that super constructor to full effect. As we've already mentioned, you use the keyword super to call the constructor of the base class. We do not use the name of the constructor. All right, so for example, we want to use like something from employee to in order to identify. We simply just say super and then pass in the appropriate variables. If a constructor definition for a derived class, though, does not include an invocation of the constructor from the base class, what Java will attempt to do is use the no-R constructor of the base class automatically. So if we look at the following definition below, and we have a no-R constructor for the class hourly employee, notice we're not using super. It'd be equivalent to this version: public hourly employee, wage rate equals 0, hours equals 0. All right, so it's assuming that we are therefore using the super constructor that exists within the employee class if employee has a no-R constructor. Now, of course, this is very good, but what is this actually doing for us? Well, this ultimately is getting us access to these variables that exist within the base class. And super allows us to do that pretty nicely. So a derived class has all the instance variables of the base class. All right, and we've kind of talked a little bit about this, but like, for example, employee has name and it has like hire date. So these are things that exist strictly within employee. They don't necessarily exist within hourly employee because they are objects of employee. But the nice thing is, because it's derived, it pulls that information. These instance variables are inherited and should be initialized. And the nice thing about this is that the base class constructor, so the one in employee, is the most convenient place to initialize these inherited instance variables. So it's going to give them that initial value, whether it's 0, whether it's an empty string, whether it's, Bob, whatever that value needs to be, that's where it's going to happen. And this is why we should always include a call to one of the base class constructors when we define a constructor for a derived class. Again, if we don't include a call to the base class constructor using our super invocation, then the no-arg constructor of the base class is called automatically. However, if your base class does not have a no argument constructor, so the no arg constructor is missing, this is setting you up for a potential error condition because Java is going to look for the no arg constructor, it's not going to see it, and it's going to throw an error. Now, much as we have already seen this, the big thing to remember is that this is a call ultimately to the base class constructor. The super call is not really much that we have to worry about from the programming side of the derived class. It's more of how we handle things within that base class. So within the definition of the constructor for class, remember we can use super as a name for the constructor of a base class. And any invocation of super, therefore, must be the first action taken. Now, the nice thing about this is if we look at this example here, so this is public salaried employee, and we have salaried employee original object. I can do a super invocation of original object. All right, so that allows us to pass in an object of that base class, so invocation of base class. So, example, constructor.salary because original object.salary. So this is, again, we're passing an object. It doesn't necessarily have to be an int or string or any other primitive type. These constructors can work same way as any other class type of constructor where you can pass in different things. For example, our date object is a date class, and we could pass in a date object here. Now to go ahead and solidify this just a little bit more, let's go ahead and look at this with our employee and hourly employee class examples. And one of the things you'll notice is we have, of course, a constructor here for employee. This is our no arg constructor. You can see we have no parentheses. We have a parameterized one with name and date, and we have a single parameter one with the original object. So this is passing in an employee object. So again, 3 different types here that we can work with. And if we look at hourly employee, one of the things you'll see is we have, again, a no arg. Now, you notice there is a super invocator here. Technically, if we were to take this invocation out, this could function still the same because what is it going to do? It's going to look and say, oh, this is a no arg. And so it's going to look back at this no arg right here to try and match those up. But I'm going to leave that in there because it's just nicer sometimes to have that in place. Now, of course, here is our parameterized one. You can see we have string, the name, the date, double the wage, the hours, and here is that super invocation again. And in here, the name and the date correspond to the name of the variables here within our parameters. And that means it's going to look to see whatever I pass in here for the name, I'm super constructing here, which means it's going to say, hey, that is going to be this name here and this date here. So it's going to get that information simply from here. I don't have to go and create a whole nother like employee object or anything like that and then try to mesh between those. No, the nice thing is this constructor, by using the super, is going to handle that for us. And of course, here is where we can pass an object, and you'll notice this is hourly employee original object. And of course, it is a super invocator, very similar to what we see here with the employee object. And if I just open one more, let's look at salaried employee here. You can see we have very similar things. We have, of course, the salaried employee here with our super invocation. We have our parameterized one with another super call using, again, the name and the date. Notice these didn't change because, again, I'm simply just accessing these 2 variables, which are corresponding to these 2 variables here within the employee class. And of course, and then we have our last method here, which is, of course, the one where it is constructing based upon a salaried employee object. And that is going to give us a little bit of things to kind of get us started here with the different things. Most of everything else we see within these classes is, of course, going to be things that we are already familiar with how to actually construct, things like accessor methods, things like mutator methods, looking at strings and toString and equal. All these things are different things that we have experience with, but now we, of course, have enough kind of know-how of how these different pieces are working that we can actually take a deeper look at these classes.